Okay, so welcome to this presentation. My name is Nilo Menezes, and I will talk about serverless microservices in the PyConES 2020, the pandemic edition. So I will try to recap a little bit, not too much, because we only have 15 minutes. So let's see how it works. First, let me make a clarification regarding the serverless application framework. The name of the framework is a little bit ambiguous because it's the name of the technology. It helps to deploy as well. So sometimes it's difficult if you are talking about serverless the concept or serverless the framework. So from now on, I will try to make the difference between both of them. Okay, so initially the serverless application framework is a set of tools created in JavaScript, but that work very well with other languages like Python, Go, and others. They are also using Node, Python, and Chocolate to deploy this package on Windows, so it works very well on Linux and Windows, and it will help you to deploy a serverless infrastructure on the cloud. Regarding the cloud provider, you can use Amazon Web Services, Google Cloud, or Microsoft Azure. Others are also supported. I will show everything using AWS because the one I'm most used with. Okay. The idea of the serverless application framework is to simplify the configuration of the infrastructure you need to deploy your application in the cloud. You can configure everything using YAML files, and you can download and read more about it at serverless.com. But what do we mean by serverless? We know that the server is still there. So when I say serverless, I put this a distinction with a space in between, so two words. The idea is you should not care about the server. Somebody is taking care of the server. Usually it's your cloud provider who is responsible to apply patches, security updates, and keep the server running. So when we are working with serverless, does not mean that the server does not exist. It only means that you should not care about the server, as the cloud provider will instantiate the server for you only when you need, and you will only pay when it's running. So most of the time it's an industry term to say somebody else is taking care of the server for you. Okay. And what about microservices? Microservice is a concept that I cannot explain in 15 minutes. So I have a few bullets here to describe the main topics, and I will also suggest some books that may bring more information if you need. So it's an architecture choice that we use to develop and deploy a new system. It's antagonize the monolithic approach, meaning that instead of deploying the whole system in a single executable, or for example a single Django application, you break the application following the business domain. So instead of having a single application that does everything, you specialize these applications in microservices. How to split, when to split, and when to use the microservices, we would need a little bit more time to talk about. Last year I presented our experience in the PyCon Spain, so you may find the video in the history of the conference. But basically, the idea of microservices is that you have parts of your application that you share no database with other parts. They will communicate only using the API, so you are free to change and deploy the microservice independently. I assume if you keep the API, they should remain compatible. And the goal of this is, for example, you can do changes. You don't have to ask the other team. It works very well if you are working in big companies and distributed teams, and it also allows each team to use their own tools and development languages depending on the scenario. Okay, so a bit about lambdas. Lambdas are function as a service. It's a kind of a cloud concept where we deploy an application already split by functions, meaning that your code is like a function call in the whole application, and the Lambda is the name they are using in AWS for this service. You need to have an account on AWS to host and test your code. You can get a free web account, a free account on the website. I think they still require your credit card, but if you don't use it a lot, you won't pay anything in the first year at least. But I advise you to read a little bit how the free tier works. And if you don't have the command line application already installed on your system, you can install it very easily with pip install AWS CLI. Okay, in the remaining of the presentation, I assume you are using Python 3 and you know the basics of Python. So I will try to focus in the serverless framework and what we are trying to show here. So about the Python serverless microservices, the idea is to combine Python with the serverless concept and microservices. And as I said, the subject itself is too big. So if you want more information, I recommend these 4 books. They provide lots of hints. 2 are by Sam Newman, the author that coined the term microservices. And this is built on top of DDD, domain-driven design. So even if you don't want to join the serverless or the microservice movement, it's very important that you figure out how domain-driven design works, what's the benefits. It can really help if you develop enterprise applications. So, as we don't have a lot of time, let's try to install and deploy your first Lambda. The idea is that you will install Node.js from the website. The URL is in the presentation. You can probably download this presentation with the videos, so check the description. And to install, just open a command prompt. Here I'm showing how it works on Windows, but it's the same on Linux. So npm install -g serverless, and you should download everything. Here I assume you already installed Node.js in the first step. And on Windows it's a simple executable. On Linux just use your package manager, so it should not be very complex. After you npm install serverless, you have a new command called serverless that you can use to create the simple application. So in the example you can see I just called serverless. It will ask 3 or 4 questions. Try to answer as I'm presenting in the image, and you should be ready to go. This will create the initial configuration file and a simple Python application that I will show in the next slides. So this is the stub application. This is the handler.py. It was created by the serverless framework from the command we gave in the previous slide. And as you can see, it's very, very simple. It's a Python function that receives 2 parameters. One is the event, the second one is the context. Here we will only be using the event, and the rest is pure Python. We are just creating a dictionary. We attach the event as in the input, so we will return the input we receive it, and we build the response. It's another dictionary, so you can see we are just setting the status code to 200, and we create the body to be the JSON dump as body that we just built using the standard JSON module from Python. So no framework, we didn't use anything yet, just the serverless framework to deploy the Lambda. Okay, so what about the configuration that was automatically generated? For the sake of the presentation, I removed the comments, but this file is quite big. I think it has 200 lines. But if you remove the comments, you get something like 17 lines. I added the events, especially the lines between 13 and 17. So you need to add this to have the same result as you have. In fact, what we did here is that we are telling the serverless framework that we want to deploy a Lambda function, and that this Lambda function will be deployed using AWS and Python 3.8. AWS support different versions of Python, so you can use Python 3.6, 3.7, 3.8, and even the old Python 2.7. It's up to you. it says that the function, when it starts, it will call handler.hello. It's simply the module name with the function name inside it. As we have a very simple application, the module name is the file name, and hello is the name of the function we just saw. It also specifies the URL we will be using to access this function. So the events HTTP will add this path to a URL that will be created by serverless. So when we call something /PyConES 2020 hello, it will call our function. Okay, so how do we move this to the cloud? To go to the cloud, we simply type SLS deploy. SLS is the short form of the serverless command. Okay, so here we have the full results of the deployment, so SLS deploy, and all the rest is automatically created by serverless. Before you deploy, you have to put your AWS credentials using AWS CLI configure. So follow the instructions to get the account and to get the key and the secrets needed to deploy. But besides that, all you need is on the slide. Okay, so the serverless deploy will package your function, meaning that it will prepare the code to be uploaded to AWS. It will check, for example, any dependencies needed to deploy, and then it will create the infrastructure as code needed to create everything you need on AWS to have your function working. So you see that uploading CloudFormation file to S3, this is automatically generated. CloudFormation is a service that does the infrastructure as a service on AWS side. So it is the one that will create the API gateway, that will also link the API gateway to your function, and so on. Then once this is done, everything is uploaded to the cloud. It will display what it just do. So we have here that we deployed the PyConES 2020 Pandemic Edition, the staging, development, the region I deployed in the United States. The stack is PyConES 2020 Pandemic Dev, so it's just composed with the stage. I deployed 12 resources. Even if I'm using a single function, there is some boilerplate infrastructure that needs to be deployed later on. It's automatically generated and deployed all together by serverless. It also says I'm not using API keys, and then I have a new endpoint. So in the endpoint, you have a full domain. This was created by the serverless framework using the API gateway on Amazon. So as you can see, our function is already running under HTTPS, which is great. So you don't have to care about the certificate. And the function we deployed is the real hello function, and we are not using Lambda layers. Okay, so to visit our home page, we just have to access this URL. I created a shortened version with bit.ly. So if you go to bit.ly PyConES 2020 serverless, you should see it. And this is the result. So as you can see, we are just returning the dictionary we receive. What I recommend you to do is to copy and paste this to your text editor, okay, and try to reindent the code. So you see lots of useful information you receive in the event when your function is called. So you have all the parameters, including the path parameters, the query parameters, but you also have, for example, the IP, the country of the caller, the URL they use, the HTTP method, and you can access all this using a simple dictionary. Okay, lots of useful information. Unfortunately, we don't have a lot of time. So what do we have so far? So far, we used our standard browser. In my case, it was Chrome, to do a GET request as in any other web application. This web application, instead of being served by a standard web server, it's served by the API gateway on Amazon website. This was created by the serverless framework. So serverless created the CloudFormation script to tell AWS, hey, I need an API gateway that you receive HTTP requests for me, and if you receive something at this path, so it's PyConES 2020/hello, forward this request to my Lambda function that I'm also uploading to you. So the API gateway will forward the request headers to the Lambda hello. Our function will be called in a server that we do not control, and it will return that dictionary with the JSON response that will then be forwarded to the browser. The idea of serverless is that you don't have to keep the function running, so this code is only active when there is a call. Usually Amazon keeps it active for a few minutes, and after a while they will destroy the instance or reuse the space for other functions. What happens if you have multiple calls? Usually Amazon will create multiple copies of your functions in different servers to generate the reply. So this is one of the benefits of serverless. You should not care about the scaling directly. It's not as hard as in a Django application where you would have to add more servers, check the CPU load and so on. So this is pretty automatic if you use Lambda functions. Of course, it's not free. There is no free lunch. There are a lot of complexity behind the scenes, but it's a very good resource that I think it's worth being explored by you. Okay, so what did we accomplish here? We didn't use any framework, and we have an endpoint running on the internet. Yes, we didn't use Django, we didn't use Flask. On the Python side, the only thing we are using is the JSON module to convert the dictionary to JSON format, so it can be understood by the browser. But we had everything. We didn't need this. We didn't need to use any special code. We didn't have to run anything before our functions. We can simply read the function from top to the bottom, and we know everything that will be done. The only framework we are using is the framework that prepares and deploys the function to AWS, but this is part of the infrastructure. So it's like what serverless does is like the scripts you would need to deploy your Django application to a remote server. So, but we are not using Django, we are not using Flask, we are not using any Python framework, just serverless. Okay, what's the idea? You can keep it very simple. You can choose which libraries you want to use, what database, how do you access it, even which version of Python. And you can also have access to all services your cloud provider enables, make available to you, like different databases, different API gateways, different queues, and etc. Okay. As I said, the main advantage is that it's cheap, millions of invocations for less than €1 per month. It's simple. You can simply read the code. You don't have to think about what was running before, what was running next, and so on. It's a pay-as-you-go system, so you know that if you don't use, you won't pay. It's very, very simple to understand, and you can start very small. So it's very good to try new ideas. You can deploy the functions independently. So for example, I have a bug here, I can deploy just that function. Serverless will let you do that. No downtime, because when you are uploading a new version, the old version is removed, but not until the new one is ready to receive requests. So what the API gateway does is that when you are uploading a new function, all requests will be handled by the old version, and when the new version is available, it will automatically reroute the new request to the new version. So your system is always on. Disadvantage is that it's difficult at the beginning, it's new, so this is something you have to learn. You get more dependent on your cloud provider, because once you start using Lambda functions, there is a tendency to use more and more cloud services. You have to use the serverless framework, install nodes, so more tools to use, and maybe you miss the framework. So what's next for you? I recommend you to have a look and create a DynamoDB table, so you'll be able to access the database. A very good Python client for DynamoDB is called PyNamo. PyNamo is excellent, and it's very easy to use. They have a good documentation. You can also add more functions, more endpoints. So we just have a GET request, but you can have any kind of HTTP request. And read a bit more about Lambda. Check the serverless Python requirements plugin in the serverless framework, because it automatically creates the zip you need. For example, if you are using external libraries, just imagine you want to install Jinja and to use templates, you can install with the serverless Python requirements. It will automatically detect that and include the Jinja package in the zip that will be uploaded to Lambda, and it's almost automatic. You will just see it passing. There are also other frameworks that help building Lambda functions with Python. So you can also have a look in AWS PyConES and also in AWS Sun. I'm letting the links in the presentation. And I thank you very much. It was very, very short. I hope I didn't went so fast, and I provided at least some hints. If you have any question, do not hesitate to send an email. My email is on the last slide. Okay, see you next time. Bye bye.